Welcome to Geometry Pre-AP. First thing I'd like you to do in your notes is I would like you to write the definition for this word and this word down. All right. Don't worry about these. We don't need this one and this one right now. All right. So pause the video and get those down. Once you have those down, let me just explain to you what an altitude is. An altitude is a segment that goes from a vertex to a side opposite and forms a right angle. And they can be drawn in lots of different ways. Altitudes do not have to be inside the triangle. They have to go from a vertex and they have to create a right angle with the side opposite or a line containing the side opposite. So this is the altitude here, this is the altitude here. They can be inside the triangle. They can even be on the triangle, as in this one. This is a right triangle. That side is the altitude, or the other side that's a right angle. This could be the altitude, either one. But all triangles have three altitudes. Median is a segment that goes from the opposite side, goes from a vertex to the opposite side, and goes through a midpoint. So like this, or like this. So it goes through the midpoint. Okay, so it says identify medians and altitudes. So when you look at this first problem, it says for triangle PQRS, is PR median and altitude or neither? And so we're looking at PR, triangle PQS. And so it forms a right angle. It has a vertex, so therefore it is a altitude. Okay, so it goes from a vertex, goes to something containing the side opposite, and therefore makes a right angle. All right, so for the next one, it says for triangle PQS is QT and median, altitude, or neither. So if it goes from a vertex, intersects the midpoint, we know that will be a median. And so therefore we have our answers. Okay, how you know whether segments are altitudes or medians? It depends on whether they go to a midpoint or they make a right angle. But be careful because perpendicular bisector does both those things. It goes to a midpoint and it makes a right angle. And that was from the last video. All right, so next it says, in these three questions, name each segment that is an altitude, a median for each of those triangles. So pause the video and do these questions. All right, so for a triangle ABC, that's the whole entire, says name a median. And so we're looking through something that goes from an A, B, or C and goes to a midpoint. So AE does that. So this would be segment AE. Okay, now name a triangle for altitude for ABC. So ABC is the whole entire triangle. We'll look for a right angle. That would be BD, because it makes a right angle right there. And then finally the median for BDC. Now we change our triangle. BDC is a different triangle now. So we have the B, the D, or the C where we start with. Has to go to a midpoint, and so that would be DE is our segment there. All right, so on the test, you're going to have to be able to pick out segments that are medians, altitudes, perpendicular bisectors, or angle bisectors. All right, so for the next one, it says, for triangle ABC, is the red segment a median or altitude or neither? And be able to explain why. Okay, so if we look here, it does go through the midpoint, and so a median would do that. It does make a right angle, which an altitude would do that, but it does not go through any of the vertexes. So since it doesn't go through the vertex, the median is out and the altitude is out. So this is neither a median or an altitude. It actually is a perpendicular bisector from the last unit. Okay, let's look at the next one. It goes from a vertex, makes a right angle, so this would be an altitude. There's no midpoints, so it's not a median. All right, so it says BD is a median, find the value of X and D and C. And so remember, that's the measure of DC. Pause video, work this problem. All right, so when you're done working this problem, you should get X is equal to 5. Okay, and so find DC, and so DC would be equal to 11. And since it's a link, it wouldn't hurt to have units by it. Okay. All right. So it says EG is an altitude. Find the measure of EGF, GEF, and EFG. So since EG is altitude, you need to mark your information to the picture. If that's a right angle, we know the other two angles also. And so therefore we can say those two angles must be 6x plus 17 plus 4x plus 3 should equal 90 degrees. Because if I take the 90 out for the right angle, there's only 90 left. So I got 10x plus 20 equals 90. 10x equals 70. X is equal to 7. When I go back and plug it back in, first of all, I know the measure of angle EGF is what I want. I want the measure of angle GEF and the measure of angle EFG. So I got all these different angles. So EGF is the first one, should be easy. That's 90 degrees. You watch, people will miss that one on the tests. And then GEF is this next angle right here. So that's 42 plus 17, so that's 59. So that means there should be, what is that, 31 degrees left? Let's check and see. 4 times 7 plus 3 is 28 plus 3, so that's 31. So 31 degrees left. I remember these are angles, so put your angle degree marks by them. Alright, so special segments inside triangles. So every triangle can have all three of these. And so there's a perpendicular bisector. When they intersect at the circumcenter. There's the angle bisector. When they all intersect, they intersect at the incenter. There's a median, where they all intersect at the centroid. And then there's an altitude. They all intersect at the orthocenter. So these are these special names. You can write those in that chart from the first video if you'd like. And this is a picture for each one also. Ask me in class and I'll talk about special properties of those. Alright, so concurrency of medians and altitudes. You can highlight these theorems, but I'm not going to put these on the test. We'll talk about them at a later date. And let's see, I think that is the end of our lesson. And good luck with your notes and your work.